There's this invisible world all around us, constantly pushing and pulling on everything. I mean, have you ever been on a bike ride fighting against the wind? Or felt that awesome rush coasting down a hill and wondered, what's really going on? It might feel like magic, but it's not. It's physics, and that's what we're going to get into.
So, let's meet Sonali and Ragini. They decided to go for a bike ride on a super windy day, looking for a bit of an adventure. But what they got was, well, a bunch of mysteries. One minute they're feeling the wind literally pushing them backward. The next, they're struggling over these rough patches of road. And then suddenly, they're just flying downhill without even pedaling. What's up with that?
And this is the moment it clicks for Sonali. She yells out something like, "This is amazing! Something is pulling us downhill, but what is it?" And that question, right there, that's the key to this whole thing. To figure out what's pulling them, we need to get our heads around one really simple but super powerful idea.
And that idea? It all boils down to two simple actions: a push and a pull.
Right, so that invisible something that Sonali was talking about, scientists have a word for it: force. And when you get right down to it, a force is simply a push or a pull on an object. That's it. It sounds almost too simple, right? But believe me, every single strange feeling Sonali and Ragini had on their bike ride, it all comes back to this one concept.
And you see these forces everywhere, all day, every day. Think about it. A fielder stopping a cricket ball, their hand is applying a pushing force. You go to open a drawer, your hand applies a pulling force. See? These aren't some weird abstract science things. They're just part of everything we do.
Okay, here's a really important thing to remember. A force isn't something an object just has. It's what happens when at least two objects interact. It's a two-way street. It's the fielder's hand and the ball. It's your hand and the drawer. You can't have a force without that interaction.
Okay, so a force is a push or a pull between two objects. Got it. But what can they actually do? What's the big deal? Well, it turns out they have some serious power. Let's break down what these forces are capable of.
All right, first up, a force can change the speed of something that's moving. Remember when Ragini was complaining about the wind pushing her? That was the force of the air, a push, slowing her bike down. So what'd she do? She fought back with her own force, pushing down on the pedals to speed right back up. Forces can also change the direction of a moving object. So when Sonali and Ragini saw that herd of sheep blocking the road, they didn't just slam on the brakes. No, they applied a force to their handlebars, and that little push was enough to change their direction and steer them right around the flock. And get this, forces can even change an object's shape. And I'm not even talking about moving it from one place to another. Just think about squishing an inflated balloon between your palms. You're applying a force, right? The balloon isn't going anywhere, but it's definitely changing its shape. So when you put it all together, the power of force is pretty incredible, isn't it? A simple push or a pull can make something move from a complete standstill. It can speed it up or slow it down, change its direction, or even squish it into a new shape. And sometimes a single force can do a bunch of these things all at once. It's wild.
Okay, so now that we know what forces can do, let's start putting them into categories. Turns out there are two main types. We're going to start with the one that's easiest to get your head around: forces that require actual physical touch.
Yeah, these are called contact forces. And honestly, the name says it all. They only work when objects are physically touching each other. Think about the girl's feet pushing the pedals, the tires gripping the road, even the wind smacking into their faces. All of those are classic examples of contact forces.
And a perfect example of a contact force, one we use all the time, is muscular force. This is just the force that our own bodies create. When Sonali and Ragini were pedaling like crazy to fight against that wind, they were using muscular force, generated by, you guessed it, their muscles.
And it's not just us humans. We've been using the muscular force of animals for thousands of years to do all the heavy lifting. I mean, whether it's oxen pulling a plow through a field or a horse pulling a cart, this type of contact force literally helped build our world.
Okay, time for another little mystery from our bike ride. Picture this, because you've definitely experienced it. You're cruising along on a flat road, you decide to stop pedaling, and what happens? The bike slows down, and eventually it just stops. But why? If you're not pushing anymore, what force is making it stop?
I mean, we just said that a force is needed to change speed, right? So there has to be some invisible force working on that bike, slowing it down. So what is it? What's the unseen culprit?
And the answer is friction. This is another super important contact force. It happens anytime an object moves over a surface. But here's the key thing about friction. It always pushes in the opposite direction of the motion. It's the ultimate contrarian force. And that's exactly why it was so much harder for the girls to pedal on that rough patch of road. There was way more friction between their tires and the ground.
All right, let's take a breath. We've figured out what forces are, we've seen all the cool things they can do, and we've dug into contact forces like muscular force and friction. Now it's time to put all those pieces together. Let's learn to see these invisible forces everywhere.
So, we're going back to Sonali and Ragini one last time. But this time is different. Now we can see their entire ride through a whole new lens. It's time to switch on our physics vision.
And just look at how it all makes sense now. The girls pushing the pedals, that's muscular force in action. The wind pushing them back, that's a contact force. The bike slowing down on that rough road, pure friction. When they turned the handlebars, that was a force changing their direction. And that amazing, thrilling rush speeding downhill, that was our original mystery. It's the invisible pulling force of gravity.
And that's really the big takeaway here. This isn't just about a bike ride. Every single thing you see moving or changing direction or changing shape, it's all happening because of a force. Every push, every pull, it's the fundamental rule of how things work in our universe.
So I'll leave you with this one last thought. Now that you've got your physics vision turned on, just pause for a second. Right now, wherever you are, what invisible forces are acting on you? What's pushing? What's pulling? Once you start looking, you'll see them everywhere.